Um,
When you can make like
what?
My favorite experiment in science is putting sodium metal into water and seeing the reaction.
My favorite experiment in science is doing the flame test with potassium.
My favorite experiment in science is making copper sulfate salt because it's basically making crystals with science.
Is the metal ions flame-tized, and different metal ions can be different colors. I think it's very beautiful, so I love it.
the one where we cut the cow's eyeball open.
For me, my favorite experiment would definitely be when we do titrations, especially ones where it changes from pink to colorless. Crazy stuff.
I guess for me it would be sublimation, because when you add the water to the dry ice, it's really cool to see the mist come out.
Circular motion in physics with Mr. Simon in the playground where I went around in a circle.
I think adding alkali metals to water. I like seeing explosions.
The pendulum experiment, but instead of using like a pendulum, you use someone on the rope and then you swing them.
I like the flame test in chemistry because it's really cool seeing a purple flame.
This lever experiment I did today, with this small mass, it can lift up this 300 grams using this
Traded solution, and you let the solution cool down and it becomes like a big blue crystal.
I like the alkali metals experiment we did in chemistry because there were some fun explosions that we got to see.
When potassium reacted with water and it made
Boom!
pH indicators to make like rainbow like acid solutions.
I like cutting things up, so I generally just like dissection.
Making salt. I like doing titrations because of the cool equipment.
In year 8, I did dissection with Miss Helen. It was really nice.
Water displacement, when we add like a base or something to an acid.
My favorite experiment? Elephant toothpaste.
Wow, so cool!
Thank you.
thank you.
Boom!
Okay guys, one last agenda item. Why should you never trust an atom? Because they make up everything! Okay everybody, thanks for today's meeting. I think that was actually one of the best meetings we've ever had. Thanks. And just one more thing before we go. I just want to reiterate the importance of never ever allowing students to ever see our top secret, super amazing book of science experiments and demonstrations. Okay? It is crucial that they never see this because I think it could literally blow their minds. Okay. And one last thing. Mike, you okay? Can I please ask you to be the teacher in charge of guarding our top secret, super amazing book of science experiments and demonstrations until our next meeting next week?
Wow, that's a pretty big responsibility, but I'm up to the task. I'll do it.
Great. So if we could all just get together and end our science meeting like we always do. What science? Yeah!
Hey guys, look what Mr. Mike dropped.
What is it?
I don't know, but it looks like a really special book. Special? It just looks like the normal A for a paperbound book to me. Let's open it and see.
Ladies and gentlemen, please welcome Year 10 and their
So, what are we doing for our first experiment?
We're going to create a tornado.
Well, that seems highly dangerous, but okay.
So, as you can see, we removed the front half of these fans and also blatantly disregarded every single fan safety manual. So do not try this without adult supervision.
Wow, this looks so... No, Larry, you can get hurt!
So, we've attached 2 rolls of toilet paper to the blades of these fans.
Now what?
We're going to turn them on. So, there's a centripetal force keeping the paper turning in a circular path. But the wind is also blowing it sideways, creating something that looks like a century.
Wow, I'm a conservation ambassador, and usually I'd be quite sad about this toilet paper usage. But I'll let this one slide, it's pretty cool.
Shingan, what are you doing, and what is this?
Oh, this? It's just one mega ultra super duper cool leaf blower machine, which can make this ball fly. Well, that seems cool, but how does it work? Come, watch closely. The air blowing up is fast and therefore has a low pressure. The air surrounding it is also moving, but quite slowly because of science?
No, Larry, it's because of gravity.
Well, you're both right. Anyways, slower moving air means there's a high pressure, pushing this ball back into the stream of low pressure air when it tries to escape it. Now, can you tell me why this happens? Because of gravity? No, Larry, it's because of science.
You can't use science to explain everything.
Yes, I can. You can use science to explain basically everything. You can use science to explain how explosions work to how airplanes stay above the ground. Science is just that cool.
Well, speaking of which, Vara, have you ever wondered how airplanes fly?
Is it because of...
Science?
No, Changan, not that again.
No, it's simple. It's because airplane wings are designed specifically so that air moves faster over the top. This creates a low pressure on top of the wing, which creates a lifting force on the aircraft.
Larry, that seems skeptical. I think you're just making it up.
Well, don't believe me? See, the toilet paper goes up and flat. Give it a try. What? Well, still in doubt? Let's bring it up to the full scale.
That's how the new principle works.
Thank you for watching.
We hope you enjoyed the show.
The words and pictures came to life. I can't believe fast moving air can do that. Let's turn the page. I want to see more.
Year 12 and the digestive system.
Good afternoon, ISP, and welcome to the Science Assembly. Today, we're going to be showing you system is pretty important because it has all the parts of the body that are needed for us to get our nutrients, aka all the good stuff, from the food and liquid we consume.
You may also have heard that the digestive system can help protect us too, and we'll show you how.
The digestive system is huge. It runs through your entire body, from your mouth at one end, all the way to, well, you'll see. We're going to give you an outside look to inside our body. Shockingly, our journey begins right here at the mouth.
I think we all know where the mouth is.
Well, what they might not know is that the mouth has a couple functions that make it specialized. For one, your teeth, but also your tongue and special glands that produce saliva. In our model of the mouth, you will be using these things to chop, tear, and mash the food. Here's a brief intro to your teeth, your canines, tear food, your incisors, chop food, and your molars, grind food down. This way, the food gets smashed into really small pieces.
Don't forget to add some saliva.
Saliva, for as disgusting as it may sound, is actually pretty useful. It helps lubricate the food on its way down and has special chemicals called enzymes to further break down the food. Once the food has been torn, smashed, all together, it's going to go through the esophagus into the stomach. The stomach is like a bag inside our body, but it's not just any type of bag.
That's right, stomach is muscular and can help mix our food really well.
And it produces a special juice. And in a special juice.
This is called stomach acid. It can help break our food down into tiny little molecules.
And kill bacteria. Terrifyingly, stomach acid is so acidic, it can corrode through surfaces like metal. So you might want to be careful there, guys. Wonderful. The stomach is incredible at mixing up the food, saliva, and stomach acid.
Usually this takes 3 hours.
Should we keep shaking it for 3 hours? Well, I am free this weekend, but alas, the small intestine awaits. The small intestine is special because it produces not one, but two special juices.
Wonderful, more juices.
One of the juices is called bile, and it's produced in the liver. Bile is actually pretty useful because it helps break down all the fatty foods that we eat. Remember this as a general rule of thumb. The more disgusting it looks, probably the more useful it is. We also have pancreatic juice, which also helps break down the food with, you guessed it, more enzymes. Muscles and intestine squish the food as it moves through the entire body. As you can see, some of the mixture gets filtered into the blood. This is because the mixture has nutrients that our body uses to eat. What she really means is that our body uses these nutrients for cell growth and energy. Once it's been mixed, it's going to go through the large intestine.
I think the fun part about this is not where it has gone, but where it's going to.
Real subtle. The large intestine is pretty useful because it helps reabsorb all the nutrients and the water that's been gone. Now it's going to get digested.
Truly a sight to behold.
As they gracefully demonstrate this process, I feel like we should take a moment to thank our bodies for going through this process on a daily basis. Thank you for watching.
Wow, how crazy was that? Can you imagine if you're a molecule traveling through the digestive system? That would be awesome.
My eyes are hurting from all this reading. Let's take a break.
Great idea.
Hey guys, look what I found on YouTube. It's our science teacher.
What do you mean?
Here, on this video. It's the teachers. Play it, play it.
Nope. Yep. Nope. Yep. extinct? No. Ever stop and think? Yeah. Ever been bored? No. Ever wonder what's the difference between sound and a fjord? Yeah. You a hater? No. Holding out until you see the data? Yeah. You will all wear goggles? No. Approximate the world making models? Yeah.
Mad scientist? No. Do I look mad flying this? Yeah. Don't know so you fear things? No. Design engineering? Yeah. Is technology evil? No. Can humans be? Yeah. Hella serious? No. Tomfoolery? Yeah. Do you always wear a lab coat? No. Does the beauty of nature give you hope? Yeah. I knew it all along. No. Is it okay to be wrong? Yeah. Did the chicken come first? No. Egg? Yeah. Scared of vaccines? No. Scared of a plague? Yeah.
Everybody's got questions. Most interesting ones don't have easy answers. Everybody's got questions. But as we get older, we tend to stop asking. Everybody's got questions. Your brain's an insatiable question machine. Everybody's got questions. And if you stay bored, you may be boring.
Where we come from? I wanna know. I'ma stay curious. Yeah. Where we gonna go? I wanna know. I'ma stay curious. Yeah. To define a problem. I'ma stay curious. Yeah. If you wanna solve it, I'ma stay curious.
Pollutable? No. Alice Font's most beautiful? Yeah. You a butt? No. Humbled and inspired by a pale blue dot? Malevolence? No. Argue from evidence? Yeah. You make it up? No. Get data by investigating till you got enough? Yeah. Straight path? No. You got class? Yeah. Stress? No. Math? Yeah.
Lack of backbone, like a tunicate? No. Can you clearly communicate? Yeah. You crew rude? No. YouTube? Yeah. Gonna be easy sailing? No. Gonna learn from failing? Yeah. Saca puntas? No. Preguntas? Yeah. Answers gonna be cursory? No. Know the importance of diversity? Yeah. Do you have to be a scientist? No. Appreciate always applying?
Yeah. Everybody's got questions.
Most interesting ones don't have easy answers.
Everybody's got questions.
But as we get older, we tend to stop asking.
Everybody's got questions.
Your brain's an insatiable question machine.
Everybody's got questions.
And if you stay bored, you may be boring.
Where we come from?
I wanna know.
I'ma stay curious.
Yeah.
Where we gonna go?
I wanna know.
I'ma stay curious.
Yeah.
To find a problem?
You gotta know.
I'ma stay curious.
Yeah.
You wanna solve it?
You gotta know.
I'ma stay curious.
Yeah.
No.
Yeah. No. Yeah. No. Yeah. No. Yeah. What am I saying? No. Yeah. Can't do it. No.
Don't please make me laugh. Myself. That's it, keep going. And turn questions. Has ever done an experience? Ever stop and think? Yeah. Ever been bored? Ever wonder what's the difference between sound and a fjord?
Sorry, this is what happens when you can science.
You all wear goggles?
Wow, our science teachers are so talented.
I know, right? They can sing and they can dance. I mean, did you see Miss Georgia?
Mr. Brian was amazing, and Miss Lena rapped just like she does in our science lesson.
Let's look at another experiment.
Great idea.
Please welcome Mr. Brian and his amazing pendulum.
I would just like to start this section off by asking a question. Does anybody here happen to know what a pendulum is? Anybody?
Swings because of gravity.
Good answer. Something that swings because of gravity.
We'll have one more.
One more.
Anyone?
A metal ball.
Yeah, basically, yeah, that's right. A pendulum is basically just a ball on a string, or it could be on a rod, I suppose. So, you've probably seen pendulums all over the place in your life and you don't even know it. Do you guys want to see a really big, destructive pendulum and break something with it? Okay, let me get it.
Brian, hold on. I thought you said a wrecking ball. That's so small. How do you expect to wreck anything with that?
Well, I was gonna pull this back and then let it go, and then it was gonna knock that over, and then everybody was gonna clap. Well, I don't really have anything bigger than this here right now.
Oh, I see it.
Aren't you like super into bowling?
Bowling? Yeah, I love bowling. I've been bowling since I was like 5 years old. I once bowled over 100.
No one cares. But have you got a bowling ball with
Do I have a bowling ball with me?
you? Yeah.
At school?
Maybe.
In the science assembly? Like a bowling ball on me? Of course I do. I have a bowling ball I bring it everywhere I go.
Now, that's going to make a much better wrecking ball, right?
I think you're right. But, what are we gonna wreck with this? It's a bit big.
Well, instead of wrecking something, we could use it to show them the law of conservation of energy. Science.
Oh yeah, the law of conservation of energy. That's a good idea. I think in order to do this, we might need a teacher volunteer. Any teachers like to, Mr. Mike. Hey Mike. Would you mind being a teacher to volunteer to help us demonstrate the law of conservation of energy?
I don't know, it sounds a little dangerous. What do you need me to do?
Well, I just need you to stand there, and I'm going to hook this up to a rope, and I'm going to bring the ball right up to your face, and then I'm going to let it go, and it's going to swing across the stage, and then come back, and it should stop right in front of your face. It should stop.
It's totally safe. You'll be fine.
I don't know, it seems a little bit dangerous. I don't want to risk this.
Well, why don't we demo it with the test dummy from science first, and then Mike will be okay to do it.
The test dummy of science, that's a great idea. We'll do it on that first, Mr. Mike, and then we'll do it on
Okay.
What I'm going to do, Mr. Mike, is I'm going to pull this ball, I'm going to hold it in front of your face like this.
Yep.
And then I'm just going to let it go, and as long as I don't give it any initial kinetic energy, then it shouldn't go back and hit anything.
Okay, there is no way in a million, quadrillion, EMC, billion years am I ever going to put my face there. I might leave the stage now. I'm not going to do it.
I don't know. I think I know what the problem was. I think I must have accidentally given that some initial kinetic energy when I let it go. But I promise you, I won't do it again here.
Okay. What do you think, guys? Should I actually do it?
Okay, Mr. Mike, so all you need to do is stand here, and this time I promise I will try not to give it any initial kinetic energy. So, okay, now, this is very serious. Everybody has to be absolutely quiet when I do this. Because if I have even the slightest distraction, and I accidentally give this some initial kinetic energy, this could be the end of Mr. Mike's face. Are we ready? Okay, we have to be very, very quiet, please. Just remember, don't move. Okay. Ready? 1, 2, 3.
That was awesome. Did you see how close the ball got to Mr. Mike's face?
My favorite part was when they smashed glass.
I think we have time for one last experiment before the bell goes.
Turn the page.
Hello everyone! We are here today to tell you how liquid nitrogen is used in some fascinating ways.
Liquid nitrogen makes up about 80% of the breathable air around us, but when condensed into liquid, it can be a little bit different.
Liquid nitrogen is very, very cold. At everyday temperature, it is a gas and only turns to liquid at negative 200 degrees Celsius.
It's useful to be able to compare this with a substance like water. Water boils at 100 degrees Celsius, which means liquid nitrogen is much, much colder than ice.
So, before we start our demonstration, we will need 2 volunteers. Mahesh is ready in the audience to pick 2 volunteers for us.
Is anyone brave enough to put their hands into liquid nitrogen?
Who wants to play liquid nitrogen?
Adina.
Get on the stage, Adina.
What are these?
Okay, these are flowers, okay? This side of the hall, do you guys think this flower is real or fake? I see. Okay, this side of the stage, do you guys think it's real or fake?
These flowers are real soft flowers. And I say, before we have our lovely volunteers put their hands into liquid nitrogen, we put the flowers in first, just to see what will happen.
And if the flowers do survive, then we'll make sure to put their hands inside as well.
Sounds fair?
Alina, can you please come here? We're going to place the flower inside and tell them why we're here, alright?
I hear sizzle.
Ranesh, why is it sizzling?
Well, the flower is so hot that it's causing the nitrogen to boil.
Please take your hand and squeeze the flower. Squeeze the whole.
Alright, all being science, we don't do an experiment just once. Because we don't know if something weird is supposed to happen or if it was helpful. So, Alina, you can go back there, and Asparagus, can you please come up? We're going to do the same thing again, alright? Tell us what you hear.
I hear a sizzling sound.
And you can see the same fog coming out again.
Take it out and crush the petals.
Wow! The petals crumble because liquid nitrogen is so cold that it freezes the water inside, causing the ice to shatter. Essentially, asparagus just squeezed many, many thin layers of ice. As water, liquid was flexible, but as ice, it could break.
Let's give our volunteers a big round of applause.
Well, Ranesh, do our lovely volunteers have any water inside them?
Yes, your body is made of water.
So what would happen if we shoved their hands into liquid nitrogen?
All of the water and blood in your hands would freeze, and if you wipe your hands, it would pretty much shatter.
So everyone, do you think we should still put their hands into liquid nitrogen?
No, we shouldn't, but once again, let's give our round of applause.
Well, since we can't put their hands into liquid nitrogen, what else can we put into liquid nitrogen?
Well, since I'm going to celebrate, I think we should put in some balloons.
Okay, what's your name? Tito. Get on stage. Ethan.
Can all of you just hold it up?
So, does anyone want to guess why the balloon expands when we take it out but shrinks when we put it into liquid nitrogen?
Do you guys know why? Tito?
Is it because it's too cold so the air becomes denser?
Yes, that's close. Then becomes so cold that some of the gas molecules condenses into a liquid.
And when we take the balloon out, the warmth from my hand transfers energy to the gas molecules inside, causing the balloon to inflate again.
So can we give a big round of applause for our workers again? I wonder what happens if we pour liquid nitrogen into something so hot like boiling water.
Well, let's try it. I'm now going to pour some liquid nitrogen into a flask full of boiling water.
That is so cool. But what happens if we try it the other way around?
Well, we don't know what will happen, so let's make sure we're all safe before we proceed. Ranesh, please put on your safety gear. Okay, everyone. I'm going to need a countdown from 5. 5, 4, 3, 2, 1. So, if you have any more questions, come find us in our chemistry lab.
Well, or just liquid nitrogen boiling.
I don't care. I just love the huge cloud of smoke.
Oh no, what now? Well, this seems like a really important boat. We better return it back to Mr. Mike.